It's a concept about irrational numbers. Let's define what irrational number is, and we'll also look at how the decimal expansion of an irrational number is. This is the last but one concept. A number S is called an irrational number if it cannot be written in the form P by Q, where P and Q are integers and Q is not equal to 0. Rational number will say can be written in the form P by Q. Irrational number is something which cannot be written in the form P by Q. Standard questions get tested quite often testing this idea. Second one, how will an irrational number look in its decimal expansion? An irrational number in its decimal form is going to be non-terminating. It's going to be infinite and it is going to be non-recurring. Just give you an example of a number like this. It could be 0.11121314 and they'll leave you with these dots saying that it is non-terminating. And look at the pattern. It's not repeating. It's not 1111. It's not 121212. It's 11121314. This is an irrational number. This is how the decimal expansion of an irrational number is going to appear. Let's get started with the questions that tested both these ideas. Start with the first one. This is a classic question, gets tested quite often. Prove that some number is irrational given that this is irrational. So I'm going to walk you through the steps literally orally and then we'll look at it in a printed form. We'll start by assuming the contrary. We'll say that 6 plus root 7 is rational. If you're saying that this is rational, we have said that in the first part, a P by Q is not a form in which an irrational number can be written. A rational number is something that can be written in the form P by Q. So we'll write it as an A by B. So 6 plus root 7, if it is rational, we are saying prove it is irrational, we are assuming it to be the contrary. So if 6 plus root 7 is rational, it can be expressed as an A by B, where A and B are co-prime integers and B is not equal to 0. So therefore, I can write this root 7 as A upon B minus 6. We'll rewrite it as A minus 6B upon B. A and B are co-prime integers. 6 is an integer. So A minus 6B will be an integer upon an integer. This value is a rational number, which boils down to saying that if A minus 6B by B is rational, root 7 is rational. But we know, and the question is explicitly stated that root 7 is irrational. Why do we have this contradicting answer? That's because of our incorrect assumption that 6 plus root 7 is rational. That's how you prove that 6 plus root 7 is irrational. I'm going to quickly walk you through how you should write this in the examination. It'll exactly state this. We are going to assume the contrary, that 6 plus root 7 is rational. We are actually trying to prove this. We are assuming the opposite. If this is rational, then we can express it as an A by B. This gets rewritten as A minus 6B by B is equal to root 7. A minus 6B by B is rational, which means root 7 has to be rational. But this contradicts what we know that root 7 is an irrational number. Why is that? Because of our incorrect assumption. If our assumption is incorrect, what is the correct thing? The correct thing is that 6 plus root 7 is an irrational number. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.